All right, today is 2.3, measures the central tendency. A measure of central tendency is a value that represents a typical or central entry of a data set. The mean of a data set. So this is mean, median, mode stuff. Mean of a data set is the sum of the data entries divided by the number of entries. You've learned how to find mean since like 5th grade or 6th grade, something like that. So to find the mean of a data set, use one of these formulas. Now they look almost exactly the same. Population is mu. So mu equals the sum of the x's divided by the number in the population. Now lowercase n is the number in a sample, but it's basically the same thing. You're taking the sum of the data and you are dividing it by the number of entries. Now this U-looking thing is called mu. It's the population mean. And this X with the line over it is called X bar. It's the sample mean. And then N, like I said, capital N is the number of entries in a population, and lowercase n is the number of entries in the sample. Example 1, finding a sample mean. Now we're going to do a lot more sample means than population means. It kind of comes back to that thing in chapter 1 where we were talking about doing surveys. It's hard to survey an entire population. Well, it's hard to find an entire population to find the mean of it too. So you'd have to get a hold of the entire population in order to find the mean. So it's much easier to find a sample mean than it is a population mean, just because of the natural tendencies. Mathematically, it's exactly the same. It's just harder to do it because of like trying to find the mean weight of every 34-year-old male in the United States. We'd have to get a hold of everybody to find the population there. Whereas we could take a sample and say of every 34-year-old male in Aliquippa. Even that is big. It would probably be easier to do every guy at Aliquippa High School in the 12th grade. Things like that. The smaller you make the sample, the easier it's going to be able to find that sample mean. Now, then you get into how does it represent the data? And so it's like a whole thing. So luckily our examples are picked out for us. Example 1, finding a sample mean. The weights for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? So basically we're just going to add all of these up. You're going to do 274 plus 235 plus 223 plus 268 plus 290 plus 285 plus 235. Then you divide by the number of numbers. So this sample has 7, so you divide by 7, and you get a mean weight of 285 or 258.6. So X bar equals 258.6. Now it's adding everything up and dividing by the number of numbers. Pretty easy. All right, height in inches of the players on a professional basketball team are shown at the left. What is the mean height? Again, we're just going to add these all up. This would be 74, 78, plus 81, a little tedious to type it all in the calculator, I'll give you that. So when we look at this, the sum of our data entries is going to be 1,193. And you're dividing that by the total. 2, 4, 6, 8, 10, 12, 14, 15. So when we divide that by the total, we get about 79.5. So our height is about 79.5 inches tall. Last part says, C says, interpret the results in the context of the data. Basically, that's saying take what you have and see if it makes sense within the context. If we came up with a number like 90.2, then you know you did something wrong because none of these numbers are even as high as 90.2. So does it make sense in the context of the data? Yeah, it falls somewhere in the middle there. All right, I'm going to show you a trick on the calculator so it's not as tedious entering all this in. Let me pull the calculator up. Okay, so this is the old TI-83. TI-84 works exactly the same for this function now. Turn it on, go to stat, and then it's on edit, push enter. And if you enter all these values in, you don't have to add them up or anything, you just enter them in. Alright, so all those values are entered in. Then you push stat again, and over to calc, push enter for one-var stats. Gives us our value, 79.5. Gives us all the information that we're really looking for. There's the min. We're going to get into the next part, the median, because that gives it for us too. The median of a data set is the value that lies in the middle of the data when the data set is ordered. Median measures the center of an ordered data set by dividing it into two equal parts. When the data set has an odd number of entries, the median is the middle data entry. When it has an even number of entries, the median is the mean of the two middle data entries. So if it has an even number of entries, then we just take the two middle ones, add them together, and divide by 2. Example 2, find the median of the weights listed in example 1. So the easiest way to do this, if you're not doing it in the calculator, is to order them from lowest to highest. I have 223, and I have two 235s. Then 268, 274, 285, and 290. Then you can just cross off, alternating from either side until you find the middle data point. Now it's pretty easy when there's only 7. You can kind of see it right away. So 268 would be your median. Second example, in the above example, the adult weighing 285 pounds decides not to participate in the study. What is the median weight of the remaining adults? So basically, you then have 223, 235, 235, 268, 274, and 290. And so our median is going to be the mean of those 2 points, or those 2 weights. So you add them together and divide by 2. It's going to give you 251.5. That's your median weight. All right. Example, the ages of a sample of fans at a rock concert are listed. Find the median age. So this is where ordering them can start to become a hassle, because we have to find the lowest value first. It's going to be 18. So find all the 18s, then find all the 19s, crossing them off as you go. You miss one number, you can screw up, like I did yesterday. I don't think any of you even saw yesterday when I did that, but that's besides the point. So all we have to really do is enter this data in, all these data points. 24. See, I'm messing up already. If we enter them into the calculator, we don't have to put them in order. Takes a little time. All right, finally got them all in. See, this says L126. That means that my next entry would be the 26th entry, which means that I should have 25 numbers here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. So perfect. Now you don't have to go up to the top of the list or anything. I was just checking to make sure I had all my numbers entered in correctly. So you push stat, calc, enter, then enter again. Now it gives you all your stats for that data set. So if we wanted to find our mean, 25.6. Sum of x, 640. So we're going to actually just push down until we find need. Your median is 24. Not too bad. Just takes a little time to enter them into the calculator, or to order them from lowest to highest here. The mode of a data set is the data entry that occurs with the greatest frequency. A data set can have one mode, more than one mode, or no mode. When two entries occur with the greatest frequency, each entry is a mode, and the data set is called bimodal. Okay, so if we look at this data set, the mode is the entry that occurs the most. So I have 274, 235, 223, 268, 290, 285, and 235. I have 235, so my mode is 235. Those are the easiest ones. You don't even have to calculate it. All you got to do is figure out which one occurs the most. Try it yourself. The prices for a sample of South Beach condominiums are listed. Find the mode of the prices. So, looking, I don't see any other 324s. I see a couple of 540s. Those jump off the page at me. See some 670s. Okay, the 540s. There's no other 540s other than the two. And then we have three 670s. So your mode equals 670. That's it. Just looking for the one that occurs the most. Sometimes none of them are going to occur the most. Like they might all be ones, you know? And then you have no mode. That's all. Finding the mode. At a political debate, a sample of audience members were asked to name the political party to which they belong. The responses are shown in the table. What is the mode of the responses? So there are 46 Democrats, 34 Republicans, 39 independents, and 5 other I don't knows. I don't know how you don't know what party you're affiliated with, but if you don't, you probably shouldn't be voting. Anyhow, Democrat would be our mode because there were 46 of them, and that is the greatest number. An outlier is a data entry that is far removed from the other entries in the data set. So I don't remember if in your notes I put anything else there. So basically, although the mean, median, and mode each describe a typical entry of a data set, there are advantages and disadvantages of using each. The mean is a reliable measure because it takes into account every entry of a data set. The problem is the mean can be greatly affected by outliers when the data set contains outliers. Then we go into what an outlier is. Outlier is a data entry that's far removed from the other entries in the data set. So if we look at this data set here, I'm going to put it into the calculator. Now when you put it in the calculator, in order to clear this old data set out, I push up to L1 and clear. Then you just push down and it all cleared out. Let's enter this data into the calculator. Let me show you can do it this way. So there are 3 620s, 421s, 322s, 23s. Two 24s and a 65. So if we're looking at this age of the students in the class, this could be one of your college classes. So we have 6 people who are 20 years old, 4 who are 21, 3 who are 22, 4 who are 23, 2 who are 24, and 1 person who is 65. You might ask why a 65-year-old would be taking one of your college classes. It's because once you hit the age of 65, college is free. Just so you know that. Go ahead and click Stat. Go over to Calc, OneVeristats. Now it tells us that our mean is 23.75. Okay? So if you're looking at this data, there are only, out of this entire data set, 1, 2, 3, 4, 5, 6, 7 people who are above 23. The rest of them are below 23. Matter of fact, we have 6 people who are 20. So our mode here would be 20. Our median is 21.5. Forgot I could just look at that on the calculator. Scroll down there. Median's 21.5. And our mean, which was the X bar, is 23.75. Now if you look at the mode and the median, they're pretty close. But the X bar is a little far out. So which measure of central tendency best describes the typical entry of this data set? I would say it's the median. And the reason it's the median is because it's representation because it's in the middle. This X bar is not in the middle because we have an outlier at 65. So if we remove that one outlier, it would greatly change the mean. Because it drops the mean down to 21.6. And so that one outlier brings the mean up by a lot. So always check for outliers when you're looking to find a measure of central tendency. Sometimes data sets contain entries that have a greater effect on the mean than do other entries. To find the mean of such a data set, you must find the weighted mean. A weighted mean is just the mean of a data set whose entries have varying weights. Weighted mean is given by the formula X bar equals the sum of X times W divided by the sum of W, where W is just the weight. Now, every one of you in here has been through one of Malik's classes, which means that you've been through a weighted mean situation, where the test scores are worth 35%, the quizzes are worth 25%, something like that. So we're going to do an example like that. You're taking a class in which your grade is determined from 5 sources. 50% from your test mean, 15% from your midterm, 20% from your final, and 10% from your computer lab work, 5% from your homework. Your scores are 86 for your test mean. So you're going to do 86 times 0.5. Then 15% from your midterm. Midterm was 96 times 0.15. 82 from your final exam. Just write these down. 98 and 100. So your final was an 82. That's 20%. So 0.2. 98 from your computer lab, which is 10%, which is 0.1. And lastly is 100 from the homework, which is 0.05. So we're going to calculate all that out. 86 times 0.5 gives you 43. Then 14.4. 16.4. 9.8. So it's 14.4, 16.4, 9.8, and 100 times 0.05 would just be 5. The minimum average for an A is 90. Did you get an A? So we take the sum of these. It's 43 plus 14.4 plus 16.4 plus 9.8 plus 5 was 88.6. It's 88.6 divided by the total. So check to make sure your percentages add up to 1. If they do, then you don't have to divide this, which in this case they do. So you got an 88.6, so you got a B, not an A. Next example, an error was made in grading your final exam. Instead of getting an 82, you scored a 98. That's a pretty big mistake. I don't think that dude should be a math teacher. 98 times 0.2. That gives you 19.6 instead of 16.4. Now, if it's me, I'd just do 19.6 minus 16.4 to figure out how much I should increase it by. Gives you 3.2, so you just add 3.2 on to 88.6. Gives you 91.8. So your weighted mean is 91.8, so you got your A. All right, mean of a frequency distribution for a sample is approximated by x bar equals the sum of x times the frequency divided by n, where x and f are the midpoint and frequency of each class, respectively. So the first thing you have to do is find the midpoint of each class. In order to do that, it's upper limit minus lower limit divided by 2. You find the sum of the products of the midpoints and the frequencies. Then you find the sum of the frequencies, which is n. It's just the total number in the sample. Then you find the mean of the frequency distribution, which is x bar equals sum of x times f over n. Finding the mean of a frequency distribution, use the frequency distribution to approximate the mean number of minutes that a sample of internet subscribers spent online during their most recent session. So I've already done the x times f for you. And you already know that the frequency is 50. And so in order to find the mean number of minutes, you do this sum, 2089, divided by the total number of the frequency. Which gives you 41.78. All right. Now this isn't in your notes, but I want you to see it. Maybe draw it out on the back of the sheet of paper or something. A frequency distribution is symmetric when a vertical line can be drawn through the middle of the graph of the distribution and the resulting halves are a mirror image. So if I took this and cut it in half perfectly, then this half of it matches this half perfectly. That's not going to happen all that often, but occasionally it will. You will notice this pattern a lot in statistics. It's called it forms a basic bell curve. And I wish I hadn't missed so much time. We would get into bell curves. A frequency distribution is uniform or rectangular when all the entries or classes in the distribution have equal or approximately equal frequencies. So this will be a uniform distribution. This is straight across on the top. And every data entry is exact, or every class is exactly the same as the one before it and the one after it. The frequency distribution is skewed when the tail of the graph elongates more to one side than the other. Distribution is skewed left when its tail extends to the left. So if I looked at this, my brain would tell me this is skewed right. It's actually skewed left. You're just checking to see which direction the tail goes. Tail goes off this way, so it is a skewed left chart. This is about the same exact thing, except that when you look at it, this data goes off to the right, which makes it skewed right because of the tail. So always just look for where the tail is in questions like this. All right, that's it for today. Nice work. Tomorrow you're going to get started on your homework assignment and your classwork assignment, and then we will go from there.